Okay, so we'll start off today. Good morning, everyone. Thank you for joining us for today's webinar, which will be regarding the EP-Cube and the Canadian Solar Design Tool. My name is Greg. I'm part of the power electronics sales team in South Africa, and I will be discussing the EP-Cube today. And joining me is Nicholas. Nicholas is one of our engineers for technical support systems and design, and he's our local expert on the design tool, and he'll do a demonstration on it a bit later.
Yep.
As I said, welcome everyone. So everybody will be muted. This session will be recorded and emailed to you. And at the end of the webinar, we will have a Q&A session. You're very welcome to use the Q&A window. If you want to be anonymous when you ask the question, please remember to tick the little box before you send your question. As this is our first SA webinar, I'd just like to introduce the power electronics team. So as I said, my name is Greg and I'm part of the residential storage team. And then we've got David de Villiers, who's our sales manager for the power electronics. And then also Tian Botha. Tian is our local technical support for pre and post sales. So I know everybody is aware of the Canadian solar modules, but did not know that we also manufacture high quality inverters and storage systems for different applications. So to discuss these applications, as mentioned, we've got the EP-Cube, which is our residential hybrid inverter for the residential projects. Then for the commercial and industrial projects, we've got the Kubank, which is 100 kilowatt, 247 kilowatt hour battery bank, all in one system, with built-in fire suppression and also liquid cooling on the batteries. Just to talk about a couple of the specifications that it's got. This system you can couple with our grid-tied or string inverters and then also the panels. Over to the utility side, this is the SolBank 3.0, which is a 5 megawatt hour 20-foot containerized system. This can again be coupled with our grid-tied inverters or MV skids. For more information on these products, you're more than welcome to contact us directly. So over to the EP-Cube. So today I'm going to discuss the EP-Cube and 7 of its main functions, which will be the all-in-one solution, quick and easy installation, and then also the safety and the warranty. So the EP-Cube, it is a single-phase residential hybrid inverter with LiFePO4 batteries. It's a quick and easy installation. It simplifies your logistics and it's also cost saving. So the cost saving comes in on your installation time and also your labor and installation material. We can see here on the picture, we've got the base at the bottom, then your batteries, and then the inverter on top. The inverter's got 2 MPPTs and you can connect a maximum of 10 kilowatt peak onto the inverter's MPPT. So with this system being stackable like Lego blocks, it saves you installation time and also, like I said, labor costs and material costs, as you don't need any battery cables, lugs, crimping, external fuses to install on the system. So it makes it quick and easy to install. Then it's a very elegant system. As you can see, it's about 24 or 25 centimeters, very slim. And the total height of the system is 1.6 meters if you install the base with the 4 batteries and the inverter itself. And as I said, you can see on the picture on the left-hand side, stackable, where you stack one battery on top of the other, and then the inverter itself. Some information on the battery, it's 42 kilograms. It is a 5 kilowatt hour battery, and it's also IP67 rated. On this picture, we can see it's got the nice handles where you can pick up the battery, and then also we can see the battery connections, where if you stack the next battery on top of it, the connection is made. Very quick and easy to do. So it's compact and lightweight, plug and play connectors, and also waterproof, as mentioned, at IP67. Then when you install the EP-Cube with the battery modules, a minimum of 2 batteries have to be installed, which gives you 10 kilowatt hours, and then you can install a maximum of 4 modules, which gives you 20 kilowatt hours. As you'll see, it can be installed indoor and outdoor with the IP rating of 65. So the batteries are IP67 rated, but the inverter is IP65. So I would suggest if you install it outside to please follow the IP65 rating. And so there's different ways of installing the EP Cube. The first one is the DC couple. That's the normal way, installing the battery and the inverter, then connecting your PV panels onto the built-in MPPT, and then the panels will charge the batteries, then feed power to your loads, and then back into the grid if you're allowed to export. We do have an energy meter that comes standard with the EP Cube for any grid limiting if you're not going to feed back into the grid. The second option is AC coupling. So this is if you've already got a system installed on a grid tie or string inverter. So this can be connected directly to the EP Cube via an additional energy meter, which can be purchased from us. And then obviously you can charge the batteries and then feed power back into the grid if needed. And then on the last one, this is then both the two options I discussed all in one. So that's DC and AC coupling. So that would be your already installed AC inverter or your string inverter with your other panels connected to the inverter's MPPT. So there's different modes that the EP Cube can be set. The first mode would be the self-consumption. So that would be the normal way we usually do the installations with your PV panels, charging your batteries, and then power feeding back into your grid and to your loads. So this is a very nice way of reducing your electricity usage and your bill. Then we've got time of use mode. There's 3 modes or 3 periods that you can use for peak, off-peak, and mid-peak. So if you are being charged a different rate during peak times, you can set the system to then discharge the battery during that time and then charge the batteries when it's off-peak rates. And then we've got the backup mode, which we use quite a bit here in SA, which would be then if there's a power failure, then the batteries would supply your loads, your essential loads. The EP Cube, it's got a functionality that comes standard with all of the EP Cubes that are being sold in South Africa. It is linked to the Eskom app. So it is a predictive power backup capability. So what that means is that it looks at any planned outages, and then the system will automatically go into backup mode and charge your batteries full. So when there's any load shedding or any power outages, you will have a full battery capacity to power your loads. When Eskom is returned back or the grid is back to the inverter again, then the system will revert back to its original setting. One thing I have to point out, for this setting to work, you must have internet connectivity with your inverter. So the EP Cube has got about 10 integrated safety features, from the battery input reverse polarity, output overcurrent protection, AC surge protection, ground fault monitoring, and then also temperature protection on the inverters and the batteries. So as you can see, this is a very safe and reliable system to install. It's perfect compatibility. As I mentioned in the previous slides, so you can install it as a new system or with an existing PV installation. Also with optimizers and microinverters. You can install high-powered PV modules as well, up to 16 amps with the built-in MPPT, and you can also connect an EV charger to the system. Then we've also got the Intelligent Monitoring app. This is an app that you can download via the Apple Store or Google Play Store. So it's available in various languages. You can monitor your system, and you can also do a system configuration via the app. It's very easy to commission your system with this app. You can also do firmware updates if needed, and you can also contact our technical support via the app. And on the EP Cube, the whole system, as mentioned, is LiFePO4 battery, so it's cobalt free, so it prevents any thermal leakages, and it's IP67 rated. But as mentioned previously, rather follow the IP65 rating. It's got an integrated ATS, so that's automatic transfer switch, which is when there's load shedding or power outage, your system will switch faster than 20 milliseconds. And we also offer a 10-year warranty or 6,000 life cycles at the 80% of the initial capacity of the batteries. This is just a little example of a system that was installed in December last year at a residential complex. As you can see, it's a very neat and tidy and slim installation. I think the slim installation is also an advantage, especially as most of the systems are being installed in a garage. So you don't want a big bulky system that you can't park your car. So being slim, it's a very great advantage. The system is working just as backup at the moment, but the client will install PV panels at a later stage. Okay, the support and training that we offer. So there's various ways of contacting us. That will be via email, the official website, hotline, or as mentioned via the app. And the distributor, installer, or the customer can contact us directly if there's any need. We offer local pre and post-sales service. And we've got the team to assist the clients. We also do installation help and support, and then on-site maintenance and support if needed. So all of this we've put together to give our clients the best possible customer support that we can offer you. And then the EPCube University. Before I discuss the university, I'll suggest just taking a little screenshot or using your mobile phone and take a shot of the QR code. So this QR code will take you straight to the website of our EPCube University. The university is a training course that we offer on the EPCube. It'll also then, after you've done the training course, you'll be a certified installer, and then using the EPCube University, you're part of our group of EPCube installers, and you can ask questions, you can spread knowledge, and also share your experience of the EPCube. Another thing I'd like to mention is that we will be doing face-to-face training on installing and commissioning the EPCube. We will release those dates on our social media platforms very soon, so please keep an eye out for that. Another thing I'd like to mention, when you follow the link or the QR code, it will take you to our UK website. You have to select the correct country, so please look for the SA EPCube University if you want to do the training. And then our Canadian Solar Design Tool. This is something that Nicholas is going to go and speak about more in depth. So there are a couple of key features and benefits of the designer. So we've put the designer together for our clients to use from when you do your initial site assessment up to when you give a report for the client. So we try and assist you as best as we can with your whole project planning. So on the design tool, as you can see, you can plan your project via Google Maps in 2D or 3D. Even if it's for residential up to utility scale projects, you can add additional obstacles to the picture or to the site. And with these obstacles, you can also analyze your shading effect that these obstacles, for example, any trees or chimneys will have on your solar panels. You can also add different solar panels that Canadian Solar has to your selections. And you can also add, if you really want to use a different kind of panel, you can add the specs manually, and then you can use the designer tool. We've also got the different Canadian Solar inverters and storage systems that you can select. So you select the inverter as well as your panels. You can also get the string configuration, which is quite helpful, especially on your commercial and utility scale installation. So you've got your whole layout of your panels on your roof, and then the system will offer you a string configuration that will be the best on stringing all of your panels with the shortest runs on your PV cables. And then after doing your whole design, you can get the system yield estimation, technical drawings, electrical designs, and also bill of material. I know this is very helpful, especially if structural engineers want any information regarding the panels and the weight and so forth that you install. You can also add self-consumption data. If you've got a site assessment and you've analyzed the consumption of the site for a couple of months, you can put that information into the designer, and it will give you the financial data and also return of investment period. And then at the end, once you've done all of that, you can create and share all of this information with your clients and whoever else needs to know all of the information. So that part is from me. Thank you for your attention. And I'm going to hand you over to Nicholas. That's going to do an example of the design tool. Thank you.
Thank you, Greg, for the introduction. Hello, everyone. As mentioned, I'm Nicholas. I provide technical support to the pre-sales in Canadian Solar. I'm working very closely with Greg and Tian and the team there in South Africa. So today we are going to see demonstration of how the design tool is used for system design for our projects or any project with our modules and our EP-Cube and other projects and other products. So basically, this is what you see in the login of the tool. It's an online tool. You just need to register an account to validate your email, and it's free of charge. You just validate it, and then you can log in. Once you have already my credentials, and once you log in, you can see how it's structured in two main parts. The string tool, it's one kind of a string sizer that with very little data will enable us to check any kind of configuration, more focused on the electrical part, and also check different configurations with different inverters, different products, depending on the project and the alternatives that we have. And then we have, on the other hand, the other part of the tool will be the plant configurator, where we can create a project from scratch, including also the physical part, as Greg mentioned before. So today, we're going to start a demonstration with a quick check on doing a project on the string tool for a residential project in South Africa with EP-Cube. To do this, we just go to New, we click in New, and then we will see how the project opens with the basic inputs. Here, we just need to include some location details. Well, first, we need to give a name to the project. This will be webinar EP-Cube. A reference, which can be April 2025. Another description, this will be PV with EP-Cube. The address is important here. If we have the exact address, it's always better because it will take all the information from our metro providers. If we just have a city or a close by town, we can just include it and it will already give a very reliable result by loading data from two providers mainly. We have Metronorm on one side and we have PVGs on the other one. I would just go with Metronorm in this case, and we see how the tool already loads all the location temperatures, and it will also on the back load all the radiation data and so on. Once we have this, we go to the PV fields. We can define up to 3 different PV fields. If needed, this could be increased. I would tell you to reach out to us directly, and we can enable this for you. But we've seen that normally with 3, it's more than enough, especially for residential projects. And in this case, I'm just going to activate 2 of them. For these, I will just click in this box for the PV field 2. And I'm going to start defining first the PV field 1 by clicking this question mark here in the azimuth. We can change it with this little bar as we want. Just going to place this one to the north, and the tilt also with the same bar on the right hand side. 14. We can also edit these numbers manually by just including the number. And once we have it 15 degrees, I'm going to click close, and there we go. For the installation type, in this case, it's going to be roof mounted. We're going to consider a house in Cape Town in this case. For the module, here we have 2 options. We will obviously recommend using Canadian Solar modules, which are already loaded here in the tool with all the data. If we already have an existing installation and want to check how the EP-Cube works with this installation, for example, we can just click here, use custom module, and we have several ways to create a new module by clicking here, including the data from the datasheet, importing the data from the ENF database, which has many of the modules are in the market right now, or we can directly import a PAN file and it will create the module for us with all the relevant data. In this case, As mentioned, we're just going to use Canadian solar modules. This for residential, I'm going to take the 6.248 TD, 450 watt. And for this slope, which is north facing, I will set 5 modules for a total of 2.25 kilowatt peak. Same for PV field 2. This one I'm going to place it more or less to the west, again with 15 degrees inclination, tilt, sorry. Roof mounted. And here we could also change the module. In this case, I'm just going to use the same 4.248 TD with 450 watt. I'm going to set here 4 modules in this slope so we can differentiate them. And once we have it, we can just go to the inverter selection. Here we have 2 options. Mainly, we can choose the hybrid inverters or all the inverters. If we don't touch anything or click any box, we will see all the inverters that are available on the market. If we click here on the box of showing only hybrid inverters, we will see how we can get the EP-Cube inverter we selected. We see here how the data is disclosed. Basically, we have basic input data and basic output data, and also the green standards that we have with the inverter of the EP-Cube. Once we have it, we click next. And we go to the string definition. Here, the system will give you options to choose different number of inverters. In this case, it's obviously 1. We click confirm. And here we see in the layout how we have both PV fields, the one with 5 modules and the one with 4 panels. The model we've chosen, azimuth and tilt, and then the inverter below here with 2 MPPTs for the EP-Cube. The way we can read this per inverter, we can click here to hide it or to show it. We will see how each inverter has the MPPTs here with the entries per MPPT. In this case, is 1 on the rows, and on the columns we will see the number of modules that we can connect to this MPPT. The system has already loaded all the relevant data and done all the calculations for all relevant parameters of tensions, currents, and power, and is telling us that minimum we would need to connect 3 modules per MPPT and maximum 10. To connect them effectively, we just need to assign 1 PV field per MPPT. Here I'm going to leave the PV field of 5 modules, and here I'm going to include the one with 4 modules, and we can do the calculations. We can do them, we would highly recommend to do them manually because it's generally pretty easy. It's pretty graphic also, and we can change them as we want. But we could also calculate them automatically if we click on the right-hand side, calculate. Obviously, we have 5 here on the first one. On the second one, we'll have 4. Can select them, deselect them, or play with them. This one is pretty simple, so I'll just set the strings, and then I have to click next. And with this, just with this, already we get highly reliable results on the radiation that we will get, the yield that we will get, and also the performance ratio, including some losses because of temperature or the inverter. We see here also the PV fields that we defined, and below we see the configuration of the inverter, basically the EP-Cube with all the relevant data that the system has calculated, also adjusted to the location, temperatures, etc. Once we have this, we could already export all this data by clicking on the top right, the printer icon, or we can continue and add the consumption and the study of the business case, basically. To do this, we activate these 2 little boxes on the top left, and we can go to the next window of self-consumption. For also on the data, important to mention that it has been the main focus of this app. Maybe it's not the prettiest when we see the interface, but it's super useful and highly reliable. The data has been validated by the Fraunhofer Institute in Germany, and it's even bankable. So yep, here on the self-consumption, we have to first define a consumption profile. We would recommend, there are a number of ways to do this. For residential, we would recommend 2 ways. We can leave it as it is and choose the monthly consumption divided by bands. Then we can fill all this data, basically looking at the energy bills. Or if we could here, instead of calculating the definition mode upload profile, we can upload our hourly profile in CSV. I'm just going to upload an hourly profile that I have prepared here for residential in South Africa of 7,500 kilowatt hour per year. Once we have this, we could view our profile here per month. We want to check the details, and then go to the next step, which will be the storage. In this case, the box of adding storage for this project is already active because we've chosen the EP Cube on the inverter configuration. And below we see how the system is already recommending us a battery's capacity of around 10 kilowatt hour after doing the calculation. So here we can select the capacity that we want. We can go up to 20. I'm going to select in this case the 10 kilowatt hour EP Cube. We go below to the graph and then we reload. And with this, we will see the monthly data, maximum production data, minimum production data of any day, the average consumption, average production. It's very useful to look at each month. Generally, here we've got January, we can go to June and July, where production will be lower. And then we can also see this on a yearly average, basically on the kind of the average day that we will see over the year, where all the production is disclosed here in the graph per hour. And on the right-hand side, we will see where the energy goes. Part of the production is going to storage, part is directly self-consumed, part is going to be injected into the grid. Once we have this, we have to save here. We would recommend to save as often as possible. In general, as a general rule, however, the system is prepared to kind of get the last step that you defined. So if for any reason you have to leave or you have to close the navigator or whatever, it will take the information and save the project for you to continue later. So here, once we have the self-consumption, we can go into the financial calculation. First, we have to set the number of years for the economical analysis as much as we want. I'm just going to leave it in 20. We have to select the currency. And in this case, we are in South Africa. And then we have to go into the PV system costs. We have 2 main ways to define this. One is the detailed way, where we go into every component and we give a unitary cost, also a cost for installation, annual fixed maintenance cost, etc. In this case, I'm not going to go into the details for this, so I'm just going to include a very general specific investment cost for the whole system, so including all components, EP Cube, installation, whatever we want to include in basically per kilowatt hour. I'm just going to set here 25,000, an annual maintenance cost of 2,500. For the annual PV module degradation, it's automatically set in 0.5, which is in line with what we have based on the modules that we selected. And then on the battery costs, here is something that we actually would not need in this case. This is thought here. There's a little explanation. If the degradation of the battery gets to a point where we would need to replace the battery over the years of the economical analysis that we are doing, we would have to include here the cost of replacing the battery. In this case, the EP Cube degradation is around 2% maximum per year. So over 20 years, we will still have a very decent state of health of the battery, and we will need this include this into the financial case. On the right-hand side, we have also the possibility to set an amount that the client wants to define, to finance, and also to include grants if there are any. We can do them fixed on a fixed rate, or to include a deduction on the tax, or a fiscal deduction on taxes over a number of years. I'm not going to include any of this. Just going to go directly to the prices. So here we've got several options. We just recommend to set an electricity purchase price and a sell price if we can include energy into the grid. I'm going to set this here in 3.3 for buying and selling. And then with this information, we can already calculate here below the return of investment of the whole system. And here we will see basically, a summary of the energy consumption, the energy production over the year. On average, the portion of this energy that goes to the battery, how it's used, how we are consuming that energy directly from the PV system, and then also the yearly return rate together with a cash flow on the right-hand side. Once we have this, we've seen. Now I'm explaining every little detail as much as possible, so you can use it on your own. But you see how in 5-10 minutes you can really define any configuration and actually change it if you want to try different ways to set the whole thing up. Once we get to this step, we can go on the top right, click the print button. You can also contact us directly by clicking in the email button icon here on the top right, and we would help you kind of getting the products in place. We'll see how I need to go out of this full screen mode. But basically, the system generates a PDF where we'll see everything that we just generated, all the steps, all the relevant data, how the inverter is configured, the self-consumption study, different graphs, and the return of investment that it's generally useful. We see also our little logo here, and that we can maybe attach to an offer to a client so they can understand what they're getting. So with this, this is basically the idea behind the string tool and how it works. Again, if you have any questions, please feel free to type them in the Q&A. We've seen some popping up already. I'm going to go into Plan Configurator now and try to explain a whole project from scratch, also including the 3D view. So as mentioned, this part of the tool, the second part of the tool, is helping us build a whole project from including the physical part. I'm just going to click on New here. And we're going to do the same. Give a name to it, reference, whatever we want. I'm just going to include April 2025. System will be scripts in PV with EPCube. And then for the location, we can check in Google Maps. I already have an address of something I've seen. In the map, I've pre-selected. We'll just take this house over here. The view can be changed as if we're using Google Maps. Actually, this is taking everything from Google Maps. We can remove the labels if we want. Once we have the location, the important thing is to place this little blue flag in the roof that we are going to assess. We can do this by selecting, we can click the flag, or by double clicking on the roof. And that's it. We have to adjust the zoom already, so we can see the whole building. Because if we get too close, then the image will be cropped, and we won't be able to work well with it. Once we have it, we click Create, and then we see again how it's going to be. The system is going to be loading everything. And to go into full screen mode again. So here we see how the system has cropped the view for our house. below, or there's a bar, we will see a bar, and on the bottom right, we will see two ways to set the light. We can set the top light with the two arrows that are pointing down here, or we can just go to this little sun and with a bar below adjust the time of the day for each day of the year. We would generally recommend to work with the top light because the definition is generally a little bit better. And then we can start already with the shapes. The menus are set on the top right. We will see one menu for the terrain utils, then another one for objects and obstacles, another one to create prototypes for our modules and our system, PV system. Then when we have created the systems, we can place them with this module, with this menu. We can place the prototypes on the slopes that we've created. We can analyze the shadow wind, and finally we can go into the inverters and do the electrical configuration. So I'm going to start with the terrain. Here there are different ways to, there are a number of ways to define the roofs that we are going to work on. The first one is the automatic one. If it's very irregular, we can just go here and with this, selecting this sketcher tool, click on the borders of the building. Once we have the first line, I would recommend to press Alt-GR, and then the system will help us set the 90 degrees angles for the shape, which is generally comes pretty handy. I'll set this building like this, more or less. Once we click on the last point, it gets defined. Here, after once we have the shape, we can move it around by clicking the white dot here, or by clicking the two axes, horizontal and vertical. Here it's already more or less placed into the building, so I'm going to directly go into the shape of the roof. In this case, for this kind of roofs, the system has a feature that detects all the slopes with the image. So we can just choose on the top right, residential type for building, and we leave it in automatic. We provide a wall height, roof height, 3 meters. I'll leave it like as it is. Maybe a wall offset, which is this C here. I will leave it in 30 centimeters. And once we have it, we just create the building. And here we will see how the system basically read pretty well all the slopes. It's not 100% of not in 100% of the cases it will be like this. I will show now a couple of ways that we can use to navigate the different shapes for the roofs. Because basically we will have this on the top right. We can apply a transparency and edit it, and we will see how the system basically adjusted the roof that was created to the image that we had. For different kinds of roofs, like this one below, for example, we can use different ways. Here we would, instead of drawing the whole shape manually with the sketcher, we can just use a predefined shape like this one. We can rotate it, and we can place it on top of the building. When we have this kind of roofs that don't have slopes on all sides, basically this one has 2 slopes here, 2 slopes here. We would recommend just creating 2 buildings with a predefined shape like this one. I will just place it here, select this vertex, rotate it. Where am I? Here. Adjust it to this first shape. To edit the shapes, we can also click here in edit vertex, and it will let us change the length of each vertex as we want. We can also click here and set the measures if we have them, a number of meters per side. And once we have it, I will go just create instead of the automatic type, a dual slope here. I will leave it in automatic as it is. I have to create building, and we have to choose a side. The side it starts creating the building is the side that we see on the left on the building here, on the right side where we set all the parameters. I'm just going to choose this one here, and we see how it created the building. If we want to go into the 3D view, on the bottom left, we can click this little cube here, and it will show us the building. Here also, to do a bit of zoom in, zoom out, we can do it with the mouse. If we click the wheel of the mouse, we can move around, and if we click the right button, we can adjust the view as well, so we can see the buildings. To complete this kind of building, we will just need to create another one here, and the system will do an overlap, kind of defining well all the slopes. I'm just going to remove this one, just a little explanation here to help you out in case of different roofs, roof shapes, and let's just work on this one here. So once we have the building created, we would go into the next menu on the top right, which is objects. In this case, using transparency, we see we don't have any object on the roof. Let's just imagine there's a chimney here. For example, I'll just go to the objects and select a chimney here. We have also windows, veluxes, every kind of object that we can place in a roof. I'm just going to select this one and place it here. I'll leave it as it is. This is generally useful if we have it on the slopes that we are going to use for the modules, because it will create some shadowing. The system then will model it, and then we can also apply an offset to them, so we won't place any modules on this area that we see here. Once we have all the objects in the roof, we can go to other objects outside the roof. It's really, for example, these trees here. We have different trees, different kinds of trees. We can set also the measurements. I'm just going to place one over here. We can adjust it also if we go into the 3D view, and on the object, we select the object and we click on scale. Here we can adjust all the parameters. I'm going to set it a little bit smaller. Another way we can set the parameters is by selecting the objects and already defining height, for example, here of 7 meters. Then the tree that will be created is already within those measurements. I'm just going to leave them as they are over there. Also, in general, an important note is that anything that we select on the map, on the work that we are doing, the system will automatically open the menu for this object, which also is pretty handy. I'm just going to move this a little bit around, but we will see later how it's affecting how the shadowing is affecting the roof. Once we have all the buildings and all the objects, we can go into creating a prototype. In this case, prototypes we can see on the right side that can be roof mounted. They can be defined for a flat roof, also for a wall mounting, which is not so common, but also possible, and also ground mounted if we are going to design a carport or a ground mounted system. We will see also this in different webinars, also depending on the interest that you have. So please feel free to ask us anything if we want to see any kind of project type. Here I'm going to define a portrait view for this portrait setup for these modules. I'm going to select the same modules that we had before. I'm going to leave this name for the prototype, create it. And then we see the system gets us to the next menu. So I can already do the fitting here on the north slope. I can apply offsets, select how to center it. If I want to lay out the modules starting from the right, from the left, I'm just going to leave it from the center in this case. And I'm going to calculate. Here we see that we can set for up to 9 modules. We want to limit this. For example, if we want to have a maximum of 5 modules in this slope, we set it here on the right-hand side with the different parameters, and then we can calculate again, and we see how it's defined. Once we have it, we click place below on the bottom right, and then we have them here as they are. I'm just going to use the same prototype for the other slope, which is going to be this one, and again calculate. Here we see the system can set up to 5 modules. I'm just going to place 4, calculate again, and place. If we want to move the modules in general that we just created, we can do that as we are doing with any kind of element. We can also select the module row and maybe change the number of modules that we had. And for example, if we have this, we can just move it and duplicate it by clicking here on duplicate. And then by selecting this yellow dot, we can just create the next row and place it, for example, over here. This way, these two will be connected, and we will have the two slopes as a rough example. Once we have all the system created on the physical side, we can already go into analyzing the shadowing. We would recommend doing this by module irradiation. We have to do this per different slope. If we have similar slopes, we can do them all together. If not, we have to simulate them separately. Here we see how here there are small losses, basically non-losses because of shadowing. So we can close this, the recap of the analysis. Then we can select the other slope, simulate shading. And here, maybe this tree, we will see there are a little bit more losses on these 2 modules, but should be also fine. Once we have this, we can go into the inverter configuration, select both slopes in this case. And here, as we are going to use an EP cube, we can click embedded battery and then string design. We see here already how the system is showing us how the most recommended inverter in this case, which is going to be the one for the EP cube. We click it, select it, and then we click calculate. This brings us to a similar configurator as the one we just saw in for the string 2. Maybe the added value here is that we can give a reference modules of the reference number of modules per string, which is generally handy when we have more inverters and bigger systems. In this case, it's pretty simple. I'm just going to set them up quickly. Once we have them, we click twice on apply to fields. Takes us back to this design, and we click below on the assign to all fields. If we activate this box of select drop point, we can also select the drop point of the cables. In this case, we have 2 drop points. If, for example, the client wants to place the EP cube on one side, we can put them together here, moving the elements as we move anything on the tool, and then assign to all fields again. And we will see how the cabling is done. Generally, the calculating the minimum length necessary, so optimizing the cable length, and then adjusting to the drop points that we selected. Once we have it, we click on save, and then we can go into the summary of the configuration we created. We'll see how we can export also drawings of the geometry of the design, and also the very simple single line diagram that we can see here. The system is already providing us, again, similar tool as the one we just saw with the string sizer, a bit more graphic, a bit more complete. We can also download the results here in Excel. We can see the technical drawings. We can see this electrical design of the strings and the single line diagram. And we can also add self-consumption and a financial study. I'm just going to go a little bit more quick here on this part, so we have some time for the questions that are popping up. Again, I'm just going to upload my profile, select 10 kWh batteries capacity, reload everything. Here it's important, if we want to see the graphs on the final report, to select. Normally we recommend the yearly printing summary, average consumption and average production. And then we can go to the financials. Again, just going to go very quickly here so we can see some of the questions. 25,000, 2,500 here. I have to select the currency first. There we go. 3.3, 3.3, and then we will see how it's calculated, more or less the same business case, but with a little bit more precise data on the location and all the physical part. Also, an additional point of this tool, of this part of the tool, is that we can set a bill of materials both on the DC side and the AC side, choosing all components and then including other costs by adding here a new one, for example, installation, adding descriptions, price. I'm not going to go into also markup, discount rates, and so on. But once we have built this bill of materials, we can create a commercial offer, which basically by feeding all this data, I'm again not going to go into details of cost and so on, but basically to show you, we can save and export a PDF file, which is a little bit more graphic, which will create a recap on everything that we've just seen, as we see here on the one that it just created. It's obviously a blank. There's no data because we didn't include anything. It's just a different way to present it, which is kind of trying to help you with the final client. If showing this will help them understand a little bit more the offer and what they're getting. With this, we will have finished our demonstration. I'm just going to show you a little extra point, which is here. If we click on the three dots here on the project that we just created, we can open the manager and we can download all the documents. If we go to the right-hand side, we can also change the title, description, reference, and so on. And we can see all the documents or share this with any colleague. You can also contact us if we can help you with anything on this design part. Or as mentioned, you can also share it among everyone that has an account in the app. In this case, I'm just going to share it with Greg. Then he will tell me if he likes the project. Here in Notify, we can leave it in yes. Basically, if you share a project with someone, they will get notified by email. They will get the link that is not always the leading to the. It's leading basically to the main login window of the Instant tool and not directly to the project itself. So we would recommend just sharing it with a comment here, and then we click add, and we can notify whoever we are sharing it with by email or by chat. So with this, we've covered basic demonstration of a project with EPCube, residential project with EPCube. Now, Greg, I've seen several questions popping up. I hope we have time to at least reply to some of them.
Yes, we did. Thanks, Nicholas. That was very informative. And as mentioned, if anybody needs more info on the design tool, please feel free to reach out to us. So just a couple of questions that have come through. Let's have a look. So is the EPCube listed on the City of Cape Town's approved list? Yes, it is. The EPCube is NRS 097 approved. And we did recently receive confirmation from the City of Cape Town that they will add the EPCube to the list. I know a lot of other municipalities in the Western Cape and rest of SA follow that list, so it's definitely approved. Then what is the maximum kilowatt peak PV power for the EPCube? So that will be 10 kilowatt peak, 5 kilowatt per MPPT, and 16 amp max per string. Then we also had a question, what is the max continuous power for the EPCube? So when you install 2 battery modules, it will be 5 kilowatts. If you install 3 or 4, it will be a maximum of 7.6 continuous power that you can use. Then on the design tool, we also had a couple of questions. So is this platform free to use? Yes, it is when you use Canadian Solar products. As mentioned on the panels, you can select the Canadian panels, or you can go and put in some data from another panel. But yeah, it's free for the Canadian products. And then can we use optimizers in the design tool? We are working on that. That's a feature that will be released in the next couple of months or in the future, that you can use optimizers as well. So that is all the questions we had. Is there anything you want to add, Nicholas?
I think it's pretty much it what we have. I mean, there are some more technical questions. We can also reply them, take them on separately. But I think we've got maybe what I see here on the max continuous power for the EP Cube. Yeah, we have that.
Yeah, we did cover that.
Yeah, we just covered this one.
Yes, 100%.
Yep.
Okay. Thank you very much. Yeah, thank you for everybody, like I said, for joining us for the webinar, and we look forward to seeing you again in the future webinars, and have a blessed day. Thank you. Goodbye.
Thank you all.